Hi everyone and welcome to the third lab of the cloud computing course. I'm Marco Iorio and today we will play with Kubernetes. In particular, in this first video, we will see how we can build from scratch a Kubernetes cluster. More in detail, we will build the topology which is depicted in picture in this video. So it is composed of three nodes. One which plays the role of the master or control plane node, that is the one that runs all the Kubernetes logic that governs the cluster, and two worker nodes. Those are the ones where our applications will effectively run. To do this setup, we will use cronlabs as usual, and I've already started some VMs to represent this cluster. So in particular, I started three VMs, one which will act as the control plane and the two worker nodes. All of those are from the Cloud Computing Kubernetes template, and one which we will use later as a management workstation. I've also changed the name so that we can easily refer to the different VMs later. So let's start actually building our cluster, and let's start from the control plane. We need to access the control plane. We can do that either from the management workstation, so using SSH, but for this time I will connect directly to SSH, to the control plane through SSH using a local terminal. So I come here, I've already copied my SSH key. If you did not already, you can upload a new one, and then I copy the SSH command. So I can start it in a new terminal. Let me get it here. I copy the command. We can see it is composed of two parts, one to connect to a bastion, a host in the between, which has a public address, and then a second part to reach our VM. So we need to continue, and then through the private key I got authenticated. So now I'm within my control plane node, the one we decided to use as a control plane. And so let's go through the lab. The first step is to change the host name of our instance. This is mainly to easily refer to it later, so to easily understand who is who. But this is also very important in the context of Kubernetes, since the host names are used to sign certificates. So if we change the host name after having created our cluster, we may incur into problems. So now I just open a new shell so that the prompt is updated, and here we can now start actually creating our cluster. So to create a cluster, we will use the kubeadm management solution, which automates all the creation, the generation of the various configuration scripts, the creation of the public certificates, private keys, the creation and the setup of the different components of the control plane, and so on. In this VM, kubeadm is already installed, as well as other two important components, which are the kubelet and kubectl. The kubelet is the component which handles the pod execution, while kubectl or kubectl is the command line tool that we can use to interact with our Kubernetes cluster. Another component which is necessary to install for the cluster is the container runtime. So Kubernetes needs something to actually start the containers. We can use Docker, we can use Containerd, as well as other alternatives. In this case, we will use Docker, as you already saw it in the previous lab. But please notice that Docker is being deprecated in the context of Kubernetes, and so probably in future releases it will be suggested to use other alternatives. To create the cluster is actually as easy as running the kubeadm init command. Here we specify a couple of additional parameters. One, to define the pod sider, so the network that will be used to assign the private IPs for our pods, as well as the service sider, which is the one used for the service. As you can see, everything already completed. So kubeadm ran some pre-flight checks. It checked that everything was ready to start actually the installation, the deployment of our cluster. It checked that we already disabled the swap, that Docker was present, and so on. And then it started doing different things. So it created the certification authority and all the private and public keys that are necessary to interact between the various Kubernetes components. And then it created the manifests for the management pods. Those are somehow fake pods which are managed differently, and those are the components that actually make our cluster alive. So everything completed, and now what we can see is that we can interact with our cluster. But first we need to get the credentials to access the Kubernetes cluster. To do so, we can copy the default administration configuration from the directory where it was created, and we copy it into .kube/config, which is the default location where kubectl goes to look when it needs to find something for the authentication. So we also updated the owner of the file so that we can access it, and then we can start typing kubectl get nodes. So with this command we are asking the API server of Kubernetes to show the nodes, so the objects as nodes, and the nodes represent the actual servers that belong to the cluster. We see here that at the moment we have only one node which actually is in a not ready status. So this is probably an indicator that something is wrong or that something has not completed yet. But let's also have a look at the containers. We can do kubectl get pods, and we do -a, which shows all the containers, all the pods that are actually running in the cluster. And here we can see some pods in the kubesystem namespace, which is the system namespace where the different Kubernetes components run. And in particular, we see the components that are needed to govern the cluster. We see etcd, which is the database. We see the API server, which is the component that answers to the various requests. So when we do kubectl get something, we are interacting with the API server. We have the kube controller manager, which puts together all the controllers that implement the Kubernetes logic. We have the kube proxy, which deals with the networking, in particular with the services in Kubernetes. And we have the scheduler, which takes care of deciding whenever we want to schedule a new pod to decide which is the target node. So we also see other two pods, the core DNS ones, which are the ones that are used to implement service discovery through DNS. And we see that also those are in pending status. So again, this is probably the indicator that something is wrong. And the problem here is that we did not yet install a container networking plugin. So Kubernetes by itself does not include any networking solution, but instead it relies on the Kubernetes on the container networking interface (CNI) to allow different providers to provide plugins that actually build and implement the pod-to-pod communication. So we have, as I was saying, different alternatives, and in this case we will use Cilium, which is a widely adopted solution. Please be aware that other widely adopted solutions such as Flannel and Calico may not properly work on Crown Labs due to the underlying technology and the fact that we are already on top of a Kubernetes cluster. So we can go on and we can we can install Cilium. To do so, we can proceed by downloading the command line interface. So sorry, let me copy it. Okay, so we download the Cilium command line interface, we just make it executable, and then we can proceed doing Cilium install, and then this flag, which means okay, use the EPAM configured by Kubernetes. So Cilium will be our networking plugin. There are different ways to proceed installing it. We selected to use the command line interface, which is provided, as this also takes care of some pre-checks and making sure that everything works correctly. But there are other alternatives based on Helm as well as based on plain YAML manifests. So it's saying that everything went okay, that the Cilium is now installed, and we can check with Cilium status which is the status. And it says, okay, we have one node which is joined and everything is green. So this is probably an indicator that the status is okay. We can also see again the status of the nodes, and we should see that now the node is ready, as networking is fine now. And we can also show the status of the pods, and we see that also the core DNS pods are now running. We also see that a couple of more pods are running, and those are the ones used by Cilium to handle the pod communication, the configuration of the network interfaces, and so on. So this is pretty much everything for the configuration of the control plane, and we can move to the worker nodes. Before moving to the worker nodes, it is worth highlighting that this configuration is actually suitable for testing, not that much for production, given that we are using only a single control plane, so we don't have high reliability of the control plane, and if it has some problems, we may lose access to the cluster. But this is perfectly fine for this configuration. So now we can move to the worker nodes, and let me come back to the Crown Labs interface, and let me copy the SSH command to access the second node. So we spawn a new terminal and we connect to the second instance. This one will play the role of the first worker. So once again, we can change its hostname for easier identification, and then we need to join this worker to the cluster. How can we do it? Actually, kubeadm provides a utility command which needs just to be copied on this workstation, on this node, and then we can join it to the cluster. This command was printed when we completed the installation, but since we lost it, we can also print it again with this command, kubeadm token create. So it creates a new token which can be used to join the cluster. We got the join command. Let me copy it. So we can run it on the worker node. This command says, okay, join the control plane, which is associated with this IP. It uses this token for authorization. So this is like a credential to prevent unauthorized nodes to join a cluster. And then the other aspects are to deal with the certification authority, which is used again for authentication. So we perform the join. Again, it performs some checks. It does some work, actually much less than in the previous case, since it doesn't have to set up the whole control plane, and indeed it already finished. So if we come back here to the control plane, we can do it once more, get nodes, and we see that one more node has joined the cluster, and that is actually ready. So we repeat the same steps for the second worker node, actually the same. Let me copy the SSH command. Okay, yes. We rename it, and we join the node. Okay, it seems I lost the command, so let me generate a new one. Remember here to prepend sudo, otherwise you will get some strange errors. And so in a few seconds we should see that also this node has joined our cluster. Let's check again. Okay, we have the two workers, one which is currently not yet ready, but I suppose if we try, it's just a matter of time. All the pods need to be started, everything. Okay, now it's ready. We can also show again the pods. Sorry, I was using the alias. We can see the pods, and we can see that some more pods has started. In particular, we see some pods about Cilium, which are running. If we use also -o wide to see some more information, let me also expand it. We can see that some pods are running, for instance, the Cilium ones already in our workers. So this is pretty much everything for the installation of the cluster. Now we can either continue to access our cluster directly from the control plane node. Actually, we can also add some utility scripts to our bash configuration. In particular, the first one enables kubectl autocompletion, while the second one creates an alias k, which stands for kubectl, which is actually widely adopted to shorten the commands. So we also source the bashrc configuration, and we can see that now we have autocompletion. So kubesystem, and then we can see all the different pods. So we can continue accessing the cluster from here, but we can also access it from a management workstation. And to see this, let me open a client VM on Crown Labs. And here, what we need actually to do to access the control plane is to copy the kubeconfig file, the one we also moved previously, that defines all the authentication parameters to access our cluster. So first we create again the .kube directory, and we copy the kubeconfig from the control plane node. First, we need to take note of the IP address. I should already have done that. And then we can copy the kubeconfig to the local machine. So, okay, password is the same as the user as always. Okay, we copied everything. So let me also again issue all these instructions. Okay, if it copies correctly. Yeah, that is fine. So now we should be able to interact with the cluster also from this management workstation. Yes, it does. Please notice that we need to have access to the IP address and port 6443 by default of our control plane. So we cannot do this from our laptop at home, because it can be accessed only from the Crown Labs or from Crown Labs. We can also have a look at the kubeconfig. So let me open it. What we see here is that it defines different aspects. First, it defines our cluster. We may have more than one. Now we have just this one, which is associated with this server. So this is the IP of our server, and this is the certification authority, which is used to sign the different certificates. Then we have a part which deals with the context, which knows which is our cluster and which is our user and possibly our preferred namespace. And then here we have the information about the user. So this is the certificate and the private key, which are used to authenticate with the Kubernetes API server. So we completed the setup of the cluster. Once more, we can see all the nodes are in ready status. We are now ready to move to the next section of the lab to start playing with different abstractions provided by Kubernetes. You can additionally also deploy a Kubernetes dashboard. I will skip this part in this video. I personally don't recommend to interact too much with the cluster through the dashboard. It's much better to use the kubectl interface, which is always available, which allows you to better understand how the different pieces work. But the dashboard may be useful, especially at the beginning, to have a visual insight of which are the different resources which are present in the cluster. So here you can find the instructions about how you can deploy the dashboard. It's just a YAML file, a configuration file, which needs to be applied. Then you have to do something to deal with the authentication, so to obtain a token which can then be used to access the dashboard. So, thank you for the attention. That's everything for this first video about Kubernetes. See you during the lab and in the next videos. Thank you again, and bye.